Now, I always say this, but only one person gets to call me Dr. Love. She's sitting back there, so just call me Lonnie, all right? So let me start with I want to have a talk or a conversation more than me talking to you. I want to have a conversation. And let me start by asking you, how many of you are in your 20s? Raise your hands. Awesome. Awesome. You are at the dawn of something very, very exciting. You are going to be changing the world over the next 30 years. I'm 50. I would do anything. I don't want to relive the 20s, I was born in the 20s. I don't want to relive my 20s, but I would die to be in your shoes. The world is going to change over the next 30 years. You're going to usher it in. You are the perfect generation for what's coming. You're perfect. You are the cell phone generation. You're very technologically savvy. Whether you are an artist, a business major, an engineer, it doesn't matter. You guys are the perfect generation for what's getting ready to come. There's a new revolution coming, a new industrial revolution, and all of you are going to be impacted by it. All of you are going to drive it. All of you are going to change our world over the next 30 years. So buckle up, get ready. You are the right people at the right time in the right place. Every 30 years, there's major changes that go. How many of you know what the Clone Wars was? Oh, come on. Somebody's got it. So what were the Clone Wars?
Are you talking fictional?
Yeah, everybody says Star Wars. Right. I got it. No, you're right, there's another one. And that was when I was your age, in the late 1980s, early 1980s, there was a revolution going. There were two things that were converging at exactly the same time. The dawn of the internet and the low-cost personal computers. Over the last 30 years, they have radically changed our society. 30 years ago, a cell phone was this big. You know, you watch movies from like the 80s, it's hilarious to see these people walking around with a cell phone like this. Now you see cell phones are getting back to that size. I don't know why. But our world changed. My parents are in their 70s. They do all online shopping. My mom is on Facebook. I mean, how many of you are getting off Facebook because your parents are on it? All right? Life, yeah. So life is changing. Life has changed. And so what's getting ready to happen is a new industrial revolution, and all of you are going to be impacted by it. All of you are going to really enjoy it. You are, like I said, the perfect generation to usher in this new industrial revolution. What a lot of people don't realize is you are actually in the perfect place. You're in the right place at the right time with the right mentality. So if you look at 30, 40 years ago, 50 years ago, we had the dawn of Silicon Valley. All right? Does everybody know what Silicon Valley is? Yeah. So you had three things that converged at exactly the same time. You had the right people at the right time at the right place. The people were two great institutions. You had, in the north, you had UC Berkeley, and in the south, you had Stanford. And there were great minds, entrepreneur-type people, really driving technology. You had the right time, which was the dawn of the semiconductor industry, and you had the right space. This big area between these two institutions was fertile ground for young people to start new companies. And the world changed because of that. So is there a new silicon? What is the new silicon? And to me, this is a curve that has a lot of people scared. It has me very excited. So if you look at manufacturing in the United States, it radically changed 50 years ago, 70 years ago. We had World War II. And during World War II, something very subtle happened that not a lot of people realized. Everybody was at war with everybody. And when you're at war, you want to do one thing. You want to shut down your enemy's manufacturing infrastructure. So I remember when I was a kid, I'd watch Hogan's Heroes, and it was like every episode, they're bombing a ball bearing plant, right? They're trying to stop the wheels of motion. They're trying to stop the ability to manufacture stuff. Everybody's manufacturing infrastructure got devastated, but one country, us. Then after World War II, we had the soldiers coming home. Our manufacturing infrastructure had been built up. We made for the world. Made in America was everywhere, right? The world, we dominated the world in terms of manufacturing. 10 years ago, we nosedived. Everything was being offshored to China. This has got politicians freaking out. We're not making stuff anymore. I get excited. Why? Because we're going away from manual labor, away from using your hands to make stuff. I saw an interview with the BBC. We had the BBC in last week, 2 weeks ago, and they interviewed some students here, and they were asked, well, what do you think about getting a job in manufacturing? And there's a problem. People think that it's the manufacturing of your parents. It's not. It's very high tech, very high paying jobs. And instead of using your hands, you know what you're using? You're using your mind to create things that are revolutionary, to create devices, to create products that get people excited. So manufacturing, we're going out with the old and in with the new. Ability to automate, to use new manufacturing processes, to make products that people can't even dream of today. That's where things are going. So is the new silicon advanced manufacturing? And a lot of people say, well, what the hell do you mean by advanced manufacturing? What does that mean? Well, what it means is highly customized products with high levels of design, making things that are extremely complex. It's changing how we design things. Brackets aren't brackets. Brackets are things of beauty. You adopt nature's way of making things. You are able to make products that people can't even imagine today. Right now, when you look at your car, there's 20,000 parts in that car. All right, we've worked with the company Local Motors. They've moved here. We went from 20,000 parts to about 50 parts. Where they're driving towards is highly customized electric vehicles. So the factory of today when you go and you buy a car, what do? You go into a dealer, you look across the floor, you say, well, I want this car. And they go, well, we don't have that car. You're going to have to get this car. This color, you might be able to pick the color of your car. You might be able to pick the interior, but not much else. Where we're going towards is highly customized vehicles, where you can go into a factory, and this factory isn't like the ones you see up in Detroit. It's like it's probably the size of your house. You walk into that factory, you sit down with a designer, and you design your car. You design it. You want it to look like the Batmobile? Great, you can make it look like the Batmobile. You want it to look like, something from Star Wars? Great, make it look like something from Star Wars. It doesn't matter. Complexity is free. We can make whatever we want. And then you come back the next day, it's done. It's been printed, it's been assembled, you can drive it away. That's just the first example. Your cell phone, get ready. Get ready. You're going to be able to have highly customized cell phones very, very soon, within a year, where you go in, you tell the people what you want, what features you want, not just like what apps. No, I want my earpiece here. I want it shaped like this. You come back the next day, it's done. Highly customized. This is where manufacturing is going. It's extremely exciting. We're getting to the point where I can put whatever material I want wherever I want it. No assembly required. That's where manufacturing is going. Now, what are the building blocks for this? How do we get there? Well, we have to have new design tools. The manufacturing processes, the way that we're making parts today is changing so fast, the software tools can't keep up. The computers can't keep up. They're so complex, the computers can't keep up. So we have to have high-performance computing. We have to have supercomputers to simulate the design tools that you'll be using, the computers you'll be using in 10 years, 5 years. So we have to have these supercomputers. 3D printing, additive manufacturing is a key. We have to be able to grow things. And the reason is it's very efficient. Today, when you make something, you typically are whittling away material. You're taking a block of metal and you're cutting it up, you're making chips. Additive is just the opposite. You're taking those chips, those powders, those wires, and you're growing a structure, much like a bee grows a honeycomb. Right? So it's very efficient. There's a company, GKN, that we work with. They're the world's largest manufacturer of aerospace parts. Their claim to fame is they produce 1 million tons of titanium chips a year. So what that means is they buy 1 million tons of titanium, ship it from wherever to St. Louis, grind it up, collect it, ship it back to be recycled. No value added. 1 million tons. They want to go to where there's no waste. That's where manufacturing's going. So what does all this mean? We've already demonstrated this. Manufacturing is going to radically change. We can make products faster and cheaper than China can send it to us. So if I make a big block of material, China's got to put it on a ship, send it on a ship over to the US. I can make big parts in a day, throw it on a flatbed truck and get it anywhere in the United States within 2 days. Much, much faster than China can. So it starts to level the playing field. So could East Tennessee be the new Silicon Valley? Are you in the right place at the right time? There's a lot of similarities. You have Oak Ridge National Lab, much like Berkeley to the northwest. And you have the University of Tennessee in the southeast. And right between is this huge swath of land that's undeveloped. All right? Now, at Oak Ridge, we have, when I mentioned all of these fundamental building blocks we need, we've got it. We got high-performance computing. We've got the world's only ability to look at the molecular structure of materials in ways that nobody else can do. That is really important for where manufacturing is going. So we're in the right place at the right time with the right tools. University of Tennessee it's not Stanford yet, but your diploma is going to get very, very valuable. It's going to grow in value over the next 10 to 20 years because you will become a Stanford. You will become a Stanford. Believe me, where the United States is going, you're going to be at the hotbed of manufacturing. So we've already put a stake in the ground. If anybody has not been to the manufacturing demonstration facility, it's in the Hardin Valley. It's not, if you've ever been to Oak Ridge National Lab, there's a big fence around it, guards. It's not really welcoming to students. It's not really welcoming to visitors. We're right in between Oak Ridge and UTK, right in the middle. And we built this facility. The people are calling it the Google of manufacturing. We have about $20 million worth of 3D printers. Metals, polymers, composites, big machines, little machines, just about every type of machine imaginable. We have about 3,000 visitors a year. I feel like a tour guide. It's nonstop. Over 800 companies come to our facility every year. We have companies that are actually placing people in our facility. We have companies moving to East Tennessee to be a part of this because they see the wave coming. So again, we're bringing scientific tools to manufacturing to kind of push it to the next level, to leapfrog the world, and creating amazing products. These are things that my group has made. Started off with a little hydraulic hand. This hand went viral. The president used it about 5 years ago. We designed and built this in a week. And there was a lot of people that got excited about how it looked. I got excited at the inside, not the outside. Inside this hand was a motor and pump. You turn it on, the fingers would wiggle. There's a video, I haven't put it on YouTube yet. One of the fluid ports has less resistance than the other. So when you power it up, one finger goes up before the rest. And I usually use that when my boss gets mad at me. I'll say, well, this is what I think of this, and I'll send it to him. And then he gets mad because the secretary reads all of his emails. But the president used this, the Secretary of Energy used this to show where manufacturing's going. It's extremely exciting. Again, with the additive, with 3D printing, there's no waste. The lighter you make a part, that means less material you have to use. That means less energy you need, less waste, less expense. Less expensive. So it's a radical change. We built a set of arms for the Navy. These arms are all 3D printed. They're all titanium. They'll float in water. Titanium arms that will float. They have the same density as the human because it's got massive cavities on the inside. There's no hydraulic hoses. All the hydraulics are grown into the structure, much like the veins in your arm, right? So it's radically different. And the most recent thing was the Cobra. This was a 6-week project. We'd worked with Local Motors, printed the car in Chicago back in September, came back and said, I want a car. I want to make a car. I want to make a really cool car. And so we had 6 weeks to design, manufacture, assemble, and test a vehicle. So we're showing that we can be very, very fast. Even for the national lab. National labs usually move at a glacial pace. We can do things very, very fast. So how can we make this manufacturing valley? Well, we need to attract industry. And to attract industry, you need a couple of things. You need energy. Well, we got energy here in East Tennessee. It's cheap. And you need materials. Think about it. Alcoa is already here. And what's getting ready to come is carbon fiber. The wave's starting. Again, there's companies already moving to East Tennessee. I'll tell you, I know of 11 big companies getting ready to move here. 11 companies. in the next year will make announcements of moving to East Tennessee. Again, we have to attract government funding. We have to attract local state funding. We need to get the three legs of the stool. We need to have industry working with academia, working with government together to really change things. So a big push we have again is with carbon fiber and composites. It's the material of choice for lightweight structures, for cars, for planes, anything that moves, we want carbon fiber. Our push, why are we doing this? We want to drive the cost down. Right now, carbon fiber costs about 25 to 30 bucks a pound. Our target is about 5 bucks a pound. If I can get carbon fiber for 5 bucks a pound, it's going to change the automotive industry. Ford is on our team, Volkswagen is on our team, and what they want is carbon fiber not on the high-end cars, they want it on the Jetta, they want it on the Fusion. They want you to be able to afford a carbon fiber car. Why do you want carbon fiber? It's going to be light. It's going to be very light, very strong, very safe. You're going to get incredible fuel economy. Right now, the target is 54 miles per gallon by 2025. To get there, we need to develop the materials now. So we need to be able to show a track record. How many of you knew that Tennessee was one of the world's largest automotive manufacturers? We're considered Detroit of the South. We are the new Detroit. We're number 4 in terms of jobs, and we're growing while others are shrinking. All the automotive companies are eyeing Tennessee. Why? We're accessible. If you look at this map, this area is right at the center of all the major arteries on the East Coast. 65% of the United States lives within an 8-hour drive of Knoxville, Tennessee. So we're very, very accessible. One thing we need to do is attract entrepreneurship and venture capital. It takes money to make something, right? And that's the one thing that I'm looking for. I'm looking in your eyes. How many of you want to be an entrepreneur? How many of you want to start a company? If you want to start a company, we can help you. We can help you make products. Because the main thing that you're concerned about is risk. We need to create an environment where reward outweighs risk. And the way to do that, I open my doors. Again, I have 3,000 visitors every year. They have access to not just the $20 million worth of 3D printers I have, they have access to Oak Ridge National Lab. So you want to create an environment where reward outweighs risk. You need to make East Tennessee the center of the universe for manufacturing. My goal is I want to get to the point where somebody in California says, you know, if I want to make a new product, I'd better go to East Tennessee to figure out how to make it. That's where we're headed. The last thing, and to me probably the most important, is creating talent. Create the talent. You guys are the talent. How many of you are thinking about going into a job in manufacturing? 1, 2. That sucks, right? Because do you realize right now there's 600,000 open manufacturing jobs, and they're not the jobs where you're sitting on a factory line. They're ones that are high skilled. The starting salaries are usually $60,000 to $70,000 a year. These are great jobs, great careers, and they can't attract the talent because you guys think that manufacturing is the factory of your parents. It's not. A manufacturing environment, go online and look at the Volkswagen plant in Dusseldorf, Germany. It's absolutely stunning. It's one of the most beautiful factories I've ever seen. Wood floors, glass walls, cars moving around on automated guided vehicles. It's absolutely stunning. That's where manufacturing is going. So we have to create the talent. We have to draw you in. For myself personally, the talent that I get, I go after high school students. Our facility is open every year to the first robotics competition. This to me is the perfect application for teaching kids manufacturing. We have about 100 to 150 high school students come into our facility. We teach them how to run our 3D printers and they print their robots. And by the time they get out, they are actually more knowledgeable about manufacturing than many college professors. Andrew Messing was here earlier. He was one of the students that I had when he started with us when he was a sophomore. He's being highly recruited now by Autodesk because he has kind of the perfect tools. There's a lot of examples of this where you can really change your future, but we need talent. So, how can we get to this? Can we get to this manufacturing valley? I think it's happening. Get ready, buckle up. It's going to change. My goal is to get out with the old, where everything had made in China. I want to get away from that. And I want to get back to where we have pride in terms of what's made in the U.S. That's it. I right at my time on it.